Hello students. Today we are going to discuss about another concepts of polynomials. In our previous class we had an elaborate discussion about polynomials. What is a variable, what is a constant, term, algebraic expression, polynomial, monomial, binomial, trinomial, zero polynomial. All these concepts we had a detailed discussion in our previous class. Now today in this class we are going to discuss another concepts of polynomial. They are nothing but called degree of a term, degree of a polynomial, general form of a polynomial, linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial. These are the concepts today we are going to discuss. Now what is the meaning of degree of a term? Degree, don't think it as it is a B.S degree or B.Com degree or M.A degree or M.Com degrees. Here in polynomials also we have a degree. What is the meaning of a degree and how to find the degree of a term, that we are going to discuss. As we know that term means a combination of variables or a combination of constants or the combination of constant and variables or a constant or a variable. Means x is a term, 5 is a term, 5x square is a term, x square into y is also a term, x cube, y square, z is also a term. All these are nothing but called terms. Now I want degree of the term. What is it mean? X. What is the variable power here? 1. Here 5 is a constant. Do you find any variable here? No, there is no variable. Even if it is no variable, we can have a variable. Means I can write it as x power 0. Now what is the power of a variable here? 0. Here what is the power of a variable? 1. Here what is the power of a variable? 2. Here the variable power is 1. Here the variable power is 0. Here the variable power is 2. Now coming to here, x is a variable and y is a variable. We have two variables here. Now how to consider? Don't worry. Here x is a variable and its power is 2. Here y is a variable, its power is 1. 2 plus 1 is how much? 3. So here sum of the variable powers is 3. Now here x, y, z, I have 3 variables. X is having the power 3, y is having the power 2, z is having the power 1. 3 plus 2 plus 1, how much? 6. So sum of the variable powers is 6. Now in all these terms, what we are considering? We are considering the variable power or sum of the powers of a variable. If you have only one variable, we are considering its power. If you have more than one variable, we are considering what? Sum of the powers of a variable. So here I have only one variable x, its power is 1. Here I have 5 is a constant, means there is no variable, means its power is 0. X square, here I have the power 2, so variable power is 2. Here I have two variables, x and y. So x is having a power, y is also having a power, so I am finding the sum. So 2 plus 1, 3. Here I have x, y, z, 3 variables. X is having a power, y is having a power, z is also having a power. Sum of the 3 powers is nothing but 6. So all these powers are nothing but called degree. All these are nothing but called degree. Here the variable power 1 is nothing but called degree of this term. What is the degree of this term? 1. Here what is the variable power? 0. This 0 is nothing but called degree of this term. Here variable power is how much? 2. What is its degree? 2. So this term degree is 2. X square into y. Sum of the variable powers is nothing but 3. This 3 is nothing but the degree of this term. X cube y square z. Here the variable powers sum is nothing but 6. This 6 is nothing but called degree. So here the degree is equal to 1. Here the degree is nothing but 0. Here the degree is nothing but 2. Here the degree is nothing but 3. Here the degree is nothing but 6. So all the variable powers are nothing but called degree of a term. Degree of a term means power of a variable or sum of the powers of a variable in a term is called degree of the term. So what is the degree of a term? Power of a variable or sum of the powers of a variables. Sum of the powers of a variables in a term is called degree of a term. For example, what is the degree of x cube y square z power 5? What is the degree of x cube y square z power 5? Now it is nothing but the combination of variables, means which is a term. Now I want its degree. How can we find the degree for this? So degree is equal to x is a variable and its power is 3, y is a variable and its power is 2, z is a variable and its power is 5. Total how much? 10. So what is the degree of this term? 10. So the degree of this particular term is nothing but 10. And one more we have. So for every constant, it is important point we need to remember. So the degree of a constant polynomial, the degree of a constant polynomial is always 0. The degree of a constant polynomial is always 0. Constant polynomials 5, minus 10, 7, all these are nothing but called constant polynomial whose degree is nothing but 0. This is about degree of a term. Next concept what we have? Degree of a polynomial. What we have the next concept? Degree of a polynomial. As we know that polynomial concept and definition we you have seen in our previous class. Now, what is the degree of a polynomial? What is the degree of a polynomial? For example, 5x to the power of 4 minus 6x to the power of 5 plus 3x square minus 11x to the power of 7 and minus 5. Now, first of all, whether it is a polynomial or not, that we need to check. First of all, is it a polynomial or not? Tell me, is it a polynomial or not? No doubt at all, 100% it is a polynomial. 100% it is a polynomial. How can you say that it is a polynomial? Yes. When we observe the powers of a variable, here what is the variable? X. What is its power? 4. Here what is the variable? X. What is its power? 5. Here what is the variable? X. Its power is 2. X is a variable and its power is 7. There is no variable, means which is a constant polynomial whose degree is 0. So all the variable powers are non-negative integers. So that we can call it as a polynomial, undoubtedly. Now how many terms we have in this polynomial? 1, 2, 3, 4 and 5. I have total 5 terms. How many terms we have? 5 terms we have. As we know that degree of a term, for every term we have a degree. Now, when it is a term, what is its degree? Here its degree is 4. And what is its degree here? Degree is 5. What is its degree? Degree is 2. What is its degree here? Degree is 7. What is here the degree? Degree is 0. So, for every term we have a degree. I have total 5 terms in this polynomial. Now, I am considering all the degrees. The first term degree is 4. The second term degree is 5. The third term degree is 2. The fourth term degree is 7. And the fifth term degree is 0. So, polynomial is nothing but what? The combination of terms. For every term we have a degree. Now, degree of a polynomial means, for example, if I am a postgraduate, my qualification is M.V.S B.Ed. So, directly, I am not getting the qualification M.V.S B.Ed. How we are getting? First, I finished my 10th class. Next, I finished my intermediate. Then graduation degree. Then post graduation. Then the technical education B.Ed. If anyone will come and ask me what is your qualification means, I can't say that 10th class, intermediate, degree, PG, B.Ed. What we say? We say that M.V.S B.Ed means the higher education. When compared to PG, 10th class is lower level, intermediate is lower level, degree is lower level. So, in all my certificates, whatever the highest priority or highest degree is nothing but my qualification. So, now my qualification is M.V.S B.Ed. Means I am considering that my highest degree qualification, whatever the highest study is there, that I am considering as my qualification. Similarly, here the polynomial is having total 5 terms. Every term is having a degree. Among all the degrees, whatever is the highest whatever is the highest. What is the highest? 7. The highest degree is what? 7. This 7 is nothing but called degree of a polynomial. So what we are doing here, first we are considering how many terms we have and finding degree of each term. Among all the degrees, the highest degree is nothing but considered as degree of a polynomial. I have total 5 terms in this polynomial. I am considering each degree. This first term degree is 4, second term degree is 5, third term degree is 2, fourth term degree is 7, fifth term degree is 0. Among all the degrees, 7 is the highest degree, so that 7 is called degree of a polynomial. 7 is called what? Degree of a polynomial. Example. What is the degree of a polynomial? What is the degree of a polynomial? Minus 7x to the power of 6 plus 3x right? Minus 6. Now it is a polynomial we have. Now I want the degree of this polynomial. How can we say? Here x is the variable. X is the variable. Its power is 6. X is the variable. Its power is 5. X is the variable. Its power is 1. Among all these powers, 1, 5, 6. 6 is the highest. So the degree is 6. So the degree of this polynomial is what? 6. So the degree of a polynomial is nothing but it is depending on the variable power. The highest variable power is nothing but called degree of the polynomial. Here we are discussing a polynomial in one variable only. We don't have multi-variables. We have only with one variable, either x or y or t or w or u or v, anything. You have only one variable polynomial. So the highest power of a variable is nothing but called degree of a polynomial. General form of a polynomial. General form of a polynomial. So what is the general form of a polynomial and how it will be? Now the general form of a polynomial, usually the polynomials we denote be p of x, q of x, r of x, g of x, etc. Polynomials usually we denote be p of x, q of x, r of x, g of x, etc. P of x means polynomial with variable x. Q of x, polynomial with variable x. R of x, polynomial with variable x. G of x, polynomial with variable x, etc. Now the general form I am talking. When we have a polynomial p of x, a0 x to the power of n plus a1 x to the power of n minus 1, a2 x to the power of n minus 2 plus and so on a n minus 1 into x plus an. This is the general form of a polynomial where a0, a1, a2, a3 and so on a n minus 1, an are called coefficients. And and they are nothing but constants. All these are nothing but called what? Coefficients, and they are nothing but constants. A0, A1, A2, An minus 1, An. All these are nothing but called coefficients, and they are nothing but constants. And x is nothing but variable. Here we have a condition of that A0 must be not equal to 0. Where is A0? Here we have. This coefficient must be not equal to 0. If it is 0, 0 into anything is 0. So there is no term of this. Now when we observe this entire polynomial, what is the highest power of a variable? Here there is no variable, and here I have a variable. Its power is 1. Like that, the highest power of a variable is what? N. The highest power of a variable is nothing but what? N. So degree of the polynomial, degree of the polynomial is n. The degree of a polynomial is nothing but what? N. So that we can call it as nth degree polynomial. What we can call it as? Nth degree polynomial. We can call it as nth degree polynomial. This is the general form of a polynomial. This is the general form of a polynomial. We discussed about different polynomials. They are nothing but monomial, binomial, trinomial. Monomial, binomial, trinomial, multinomial, all these are based on number of terms. If a polynomial has only one term, we call it as a monomial. A polynomial is having two terms is called a binomial. Having three terms, trinomial. Having more than three terms, multinomial. Now, what is the meaning of linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial? All these are based on degrees. All these are depending on degree of a polynomial. Degree of a polynomial. Linear polynomial. Linear polynomial. So, what is linear polynomial? Means polynomial with degree 1. Polynomial with degree 1 is nothing but called linear polynomial. As we know that degree of a polynomial, the highest power of a variable is nothing but called degree of a polynomial. Now, once if you know how to find the degree of a polynomial, then we can come to know that linear polynomial. What I am giving the definition? Polynomial with degree 1. Polynomial with degree 1 is called linear polynomial. For example, x. Here x is a polynomial, and what is its degree? 1. So that we can call it as a linear polynomial. X plus 5. Here x is having the power 1. So it is also a linear polynomial. 7 minus 6 is also a linear polynomial. 5x minus 3. Etc. All these are nothing but linear polynomials. Why? Because in this polynomial the variable power is 1. Here the highest power of a variable is also 1. Highest power of a variable is also 1. Highest power of a variable is also 1. In all these polynomials the degree is how much? 1. So that we can call it as a linear polynomial. The general form of a linear polynomial, the general form of a linear polynomial is ax plus b, where a is not equal to 0. Ax plus b. This is the general form of a linear polynomial. In this, a and b are nothing but real numbers, and x is a variable. And what is the power of a x? 1. And a must be not equal to 0, I am telling. For example, if it is 0, 0 into x is 0, there is no term. Then what you have? You have only constant. What is the degree of a constant? 0. So we can't call it as a linear polynomial. Linear polynomial means polynomial with degree 1 is called linear polynomial. The general form of a linear polynomial is ax plus b. Next we have quadratic polynomial. Next one what we have? Quadratic polynomial. Now you can understand what is quadratic polynomial. When the degree is 1 is called linear polynomial. When the degree is 2, polynomial with degree 2. Polynomial with degree 2 is called quadratic polynomial. For example, x square minus 5, x square plus x, 3x square minus 5x plus 7, etc. All these are nothing but examples of quadratic polynomials. Now you can observe x square and its power is 2. X square minus x, here the power is 2. X square plus x, here also the power is 2. 3x square minus 5x plus 7. The highest variable power is 2. 2, 2, 2, 2. So the highest variable power what we have? 2. So that is called degree of a polynomial, and all these polynomials are nothing but called quadratic polynomials. Now the general form of a quadratic polynomial is ax square plus bx plus c, where a is not equal to 0, a comma b comma c are nothing but real numbers. So this is the general form of a quadratic polynomial. Ax square plus bx plus c, and here the leading coefficient. X square is the highest variable term, and its coefficient a must be not equal to 0. Then only we can call it as a quadratic polynomial. So monolith linear complete, monolith quadratic. Now cubic polynomial. Now what is our concept? Cubic. Now you can understand what is cubic concept. Cubic polynomial. So what is the meaning of cubic polynomial? Cubic polynomial is nothing but what? Polynomial with degree 3. Polynomial with degree 3 is called cubic polynomial. Polynomial with degree 3 is called cubic polynomial. So x cube minus 5, x cube plus x square minus x, or 5x cube minus 7x square minus 9x plus 10, etc. are the examples of a cubic polynomial. When we observe here, the highest power of a variable is 3. In this polynomial also, the highest variable power is 3. In this also, the highest variable power is 3. In this also, the highest variable power is 3. All these polynomials is having the degree 3, so that they are nothing but called cubic polynomials. So polynomial with degree 3 is called cubic polynomial. Now the general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a is not equal to 0, a comma b comma c comma d belongs to real numbers. This is the general form of a cubic polynomial. And the last one is biquadratic. Last one is what? Biquadratic polynomial. As we know that quadratic is nothing but what? 2. Bi is nothing but again 2. So 2 2s are how much? 4. So finally we have biquadratic means with a degree 4. Polynomial with a degree 4 is nothing but called biquadratic polynomial. For example, x power 4 minus x cube, or x power 4 minus 7x cube plus 5x square minus 11x plus 20, etc. All these are nothing but called biquadratic polynomial. Means here the variable power is 4. Here also the variable power is 4. Variable power is 4, the highest variable power. In all these polynomials the degree is 4, so that these polynomials are called biquadratic polynomials. So the general form of a biquadratic polynomial is ax to the power of 4 bx cube cx square plus dx plus e, where a is not equal to 0 and a comma b comma c comma d comma e are nothing but belongs to real numbers. These all are nothing but coefficients, constants. Here x power 4, what is its coefficient means? Nothing is there. Nothing is there means by default you have 1. What is the coefficient of x cube? Minus 7. Coefficient of x square is plus 5. Coefficient of x is minus 11. And here 20 is constant. So all these are nothing but constant. So a, b, c, d, e are nothing but real numbers. So when the degree is 1, we call it as linear. Degree is 2, we call it as quadratic. Degree is 3, we call it as cubic. Degree is 4, we call it as biquadratic. Now you may ask that, sir, if it is 5th degree, if the degree is 5, what we call? There is no special name for those polynomial. Simply we call 5th degree polynomial. If the degree is 6, 6th degree polynomial. If the degree is 7, 7th degree polynomial. If the degree is 8, 8th degree polynomial. If the degree is 10, 10th degree polynomial. If the degree is 100, 100th degree polynomial. So these are the types of polynomials we have based on the degree of the polynomial. This is about our concept with related to degrees of a polynomial. So with these concepts we stop our class. In our next class we come to discuss a few concepts related to polynomials. They are nothing but zeros of a polynomial, how to find zeros of a polynomial, and how many zeros of a polynomial are there. That and all we discuss in our next class. With these concepts you can try our exercise 2.1, and also you can prepare your own notes by watching the video as well as by reading your textbook. Hari Om. Thank you.